So today the technology hates me. This is the fifth time, that is not an exaggeration, that I've recorded this video. Something keeps messing up with the audio, and I'm hoping that I can avoid that with this fifth iteration of our notes. Anyway, so we're looking at sampling distribution of the difference between two sample means. We're taking two populations, we're finding the mean of the sample of each one of those populations, and then we're finding the difference that exists between those means. And we can make inferences based upon the difference that exists between the means. For example, if we were saying that women on average live longer than men, our null hypothesis there is that women and men live the same average number of years. The alternative hypothesis would be that women, the average lifespan of women is greater than that of men. And so we would take samples of women and men. We would look at how long this particular group of women have lived, and then we would look at how long this particular group of men lived. And we would find the average for both groups, and then we would compare those two averages, and there would probably be some sort of a difference between them. But what our goal is to determine whether or not that difference is statistically significant at some confidence level, enough for us to say, yes, women do live longer than men, or no, the data shows that women on average do not live longer than men. Thus, we would not reject the null hypothesis, and our claim would be that our data shows that women and men do on average live the same amount of time. And we're going to kind of illustrate that a little bit more as we go. There's not going to be a lot of computation in today's notes. Should be relatively straightforward, hopefully proceed pretty quickly. So with our first example, we're kind of illustrating how we generate two samples of the two populations, and we create this independent sample set based upon the two populations that we're studying. So for our purposes here, for example, one, we're talking about two very small populations. It's very unrealistic. We have a population of 3 males, population of 4 males. The 3 males are DB, Brady, and Jacob. The females are Chelsea, Misty, Jamie, and Taylor. And suppose that we want to take a sample of size 2 from the male population, sample of size 3 from the female population. So for part A, we want to list the possible pairs of independent samples. So let's first find the samples that we can generate from each one of the individual populations. So for the males, a sample of size 2, we could have DB and Brady. We could have DB and Jacob. Or we could have, all the order that I have them listed, we could have Brady and Jacob. For the females, we have 4 to choose from, and we're looking for a size 3 sample. So we would have Chelsea, Misty, Jamie, Chelsea, Misty, Taylor, Chelsea, Jamie, Taylor, and then Misty, Jamie, and Taylor. And those are our 4 samples that we can generate of size 3 for all the females. Now, part A just says list the possible pairs of independent samples. So these are the independent samples per population. What we want to look at is the number of possible samples that we can generate for our particular study, whatever it might be. So it's really kind of simple. We would just take Dawson or DB and Brady, and we would match them up with all 4 female samples. So we'd have DB, CMJ, DB, MT, DB, CJT, DB, MJT. And then we would move on down the list on the male side, and now we would do the same thing with DB and Jacob. We'd match them up to all 4 female groups. And then finally we would do Brady and Jacob, and we would do the same thing, match them up to all 4 female groups. And if we count, we see that over here on the right, we have 12 total possible samples that exist from our two populations respectively. And that just kind of leads us into part B. It says if the samples are selected at random, determine the chance of obtaining any particular pair of independent samples. So our independent pairs would be a group from the males, a group from the females, and we have a 1 in 12 chance of selecting any one of those particular samples. What we want to do next is kind of look at how do we establish the hypothesis test for these two different populations. And it's not anything that's too difficult to comprehend. It's nothing really new from what we've been doing. We're just making sure that we understand what we're looking at right now is the difference between the two means. That's it. So here, for example, too, we're talking about the mean salaries for professors at private institutions and the mean salaries for professors at public institutions. And we just want to determine whether or not those two salary means are different. So when we see the word different, we're talking about a two-tailed test where it's not equal to. The other alternatives would have been a less than, which would have been a left-tailed test, greater than, which would have been a right-tailed test. So for part A, we're just establishing the hypothesis test. We're not going to conduct the test. We're just setting it up to make sure that we understand the terminology and the symbols that we're going to be using. So we have two populations. We have population 1, which is the private institution professors. And then we have population 2, which is the public institution professors. And what we're comparing, our attribute here, is the mean average salary. So mu sub 1 is the mean salary for private institution professors. And mu sub 2 is the mean salary for public institution professors. So our hypothesis test is, at this point, easy to establish. The null hypothesis has not changed. It's that the two means are equal to one another. The alternative hypothesis for this one is that mu sub 1 is not equal to mu sub 2 because we established that they are different, so we know we're talking about a two-tailed test. For part B, we are given some data. I should have labeled which was which, and I did not. But the left side here is private institution. The right side is public institution. And we're just looking, we're not going to come up with any critical values or anything like that. We're just making sure we still understand how to set up the hypothesis test and what the implications are of the hypothesis test when we're comparing two population means. So what we want to do for this particular problem for part B is discuss the use of this data and to make a decision concerning that hypothesis test. So the whole premise here is that we're looking at the difference in the means of the two populations. So it would make sense that we would compute the means of the two samples. So remember, for a sample mean, you just simply take the sum of all the values in the sample divided by the sample size, and you'll have the sample mean. So here for the private institutions, the sum of the values is 3,446.8. Our sample size is 35. So that gives us a sample mean of 98.19. For our public institutions, we would compute the sample mean, and we're just adding up all the values from the data set divided by the sample size. And here we would have 2,495.4. Sample size is 30. We simplify that, we get 83.18. And since we're talking about the difference between two sample means, we need to compute the difference between these two sample means. So that would be x bar sub 1 minus x bar sub 2, which would be equal to 98.19 minus 83.18. And when we simplify that, we will find that we have 15.01. And in the context of our problem, that 15.01 is $15,010. So what we're essentially looking at is this $15,010, is it significantly, statistically significant enough for us to conclude that there does exist a difference between the average salaries of public institution professors versus private institution professors? Maybe this $15,010 difference is an anomaly based upon our particular sample that we generated. We could generate another sample where the difference is much smaller, or we could generate another sample where the difference is much larger. So that's what we're doing when we talk about these confidence intervals and these hypothesis tests, because again, it's unrealistic to sample or to survey an entire population when it's much easier to do a sample. But we still have to make sure that we understand that those samples can contain values that are not typical of the entire population. So that's why we do these hypothesis and confidence intervals. With the hypothesis test, nothing has changed. Null hypothesis is that the two are equal to one another. The two-tailed test, left-tailed test, and the right-tailed test are still the same. What I really would encourage you guys to do is take a minute to read over these three cases that are illustrated here. That just kind of helps you understand how to interpret the confidence intervals. That's one of the things that I think that's given some of you some fits. So I've created only three cases that we will encounter with the endpoints on a confidence interval. The first case is where they're both positive. The second case is where they're both negative. And then the third case is where one is positive and one is negative. And then that helps you to see how to write out your interpretation of that confidence interval. Our notation is still the same. We're just using the subscripts to indicate which population it refers to. Our standard deviation for the sample means, the difference in the sample means, is found right here. We would just take the variance of sample 1 divided by its sample size, plus the variance of sample 2 divided by its sample size. Take the square root of that sum, and that will give you the standard deviation of the difference in the sample means. And then we also have how to compute the z-score, which we'll talk about more in an upcoming set of notes. But that just shows you right there illustratively how to compute that sample mean, or that z-score, using the data that we're given. And then that will lead us to the homework problems. I told you guys we're going to cut back on the homework some here, but I'm going to ramp up the due dates. So for today, I want you guys to do question number 2, and I want you to do question number 5. Those two questions will be due by midnight tomorrow. Probably won't take you more than 15 or 20 minutes to do both of them together. So I would suggest that you go ahead and get them knocked out. And if you have questions, ask me. But don't forget that they are due tomorrow. And I hope everybody's doing well, and I will be talking to you soon.